Good
Good af-
afternoon.
Oh, go ahead.
Oh, go ahead. No, you go ahead. Sorry. You were going to do the intro
No
for me.
problem. Good afternoon. Welcome you to the Improving Talks. I've got Daniel here with me. Daniel is one of our senior consultants with the deep expertise in the platform engineering space. His deep knowledge is highlighted by his certifications across AWS, Azure, and GCP. And today he's going to be sharing some insights on a really critical aspect of cloud computing that often doesn't receive enough attention. So what does come after cloud deployment? As your application goes live, it's crucial to shift your focus to effective cloud operations to ensure seamless performance, scalability, and reliability. Daniel will guide us through the essential strategies for maintaining and optimizing your cloud environment post-deployment. So without any further ado, here's Daniel.
Thank you so much, Lynn. I appreciate it. Sorry for cutting you off there at the beginning.
No
So, this presentation is called Keep It Safe and Running. Congratulations. You have migrated your application from on-premise to the cloud environment. Awesome. The one thing I think that a lot of cloud migrations lack is kind of the plan for day two. Many of the cloud promises have been kind of a wave of hand. It is to say that you can go and fire all your operations people if you put your stuff in the cloud because it just works. We'll just put it up there, it'll all be working and you'll be fine. That totally goes against what, say, the finer print of cloud computing is. They talk a lot. I'll use AWS as an example. That's the one that I know the best and have the most expertise in. They talk often about shared responsibility. What shared responsibility means is that AWS will do the things they're supposed to do, but you have to do the things you're supposed to do. And that doesn't mean that you can put stuff in the cloud and then wash your hands and say, okay, we're good. Everything will just run in there in perpetuity, and we can just put upgrades up there. No, that's not going to work. That's not how it is. So the question is next. Oh my clicker is not working. Beautiful. That's okay. We got a mouse. Back up. Okay, so what now? Kind of what are some things to think about when you're talking about advanced cloud operations? I think a good spot to start, particularly if you're an AWS, but the cloud tends to borrow and copy from each other. So the Azure one's almost exactly the same as this. AWS has something called the 6 pillars of well-architected framework. Those pillars are operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. These data centers use a lot of power, and they're always trying to look for ways to make it greener so that they don't look like villains that are sucking all the power off the grids, particularly in places like Texas that have had grid problems, of the last couple of years. But anyway, the point is operational excellence, security. We need to make sure that we have something that is working correctly. We want to make sure it's secure. We want to make sure that it stays. Oh, sorry. Oh, whoa. Gosh, hold on a second. Oh my. There we go. We want to make sure that it stays out there. You want to make sure that it keeps running. We want to make sure that we've got our resources partitioned such that everything is working correctly and that we're not buying more than we need and we're not buying too little. Lynn, if there's any questions that come up in the chat, you can just stop me at any time and we can address.
Sounds good. Yeah, I just put a note out there to everyone to feel free to throw out a question if they have it.
I'm somebody that I don't mind stopping and discussing if we need to go deeper. So just let you guys know that. And of course, cost optimization. That's one of the things that I always think a lot about in the cloud, because people that move from on-premise to the cloud often are pulled with promises that everything will be cheaper. It could be cheaper, but there's also a lot of room for maybe getting charged more on things that you thought were going to be cheaper. So keeping your eye on all these things is something that you really need to do if you're going to move to the cloud. Okay, so we're talking cloud ops today, but I'm not going to cover some of the usual suspects just because we're really wanting to focus on logging and monitoring type stuff. So we're not going to talk about provisioning and deployment. The CI/CD stuff will be covered in a session that's part of the platform engineering series that we are doing this month in July, every Wednesday at 12 noon Central, 1 o'clock Eastern, it's 11 o'clock Mountain, 10 o'clock Pacific. Any other time zones you want to throw in there? So we will have a CI/CD one that is very targeted at that. Networking and connectivity, those are big topics. We're not going to talk about that either in this one. We're not going to talk about automation or orchestration. So, going into containers, that's a big cloud ops thing, but that one is not going to be covered. Change in configuration management, stuff like putting your code in Git, putting your containers in something like ECR or ACR, or even Docker container storage. We're not going to talk about that. I wanted to kind of shape this to talk about some of the topics that maybe we're not as familiar with. Some of these things like automation, like provisioning and deployment, these are kind of the sexy topics for DevOps. These are things that are talked about a lot. So I wanted to kind of get to some of the things that aren't talked about as much. Okay, so here's how I'm going to do it. So I really want to do this in a way that kind of makes sense to me, and hopefully it makes sense to you guys too. I wanted to throw out the sample AWS application here, and I'll kind of go through it a little bit in case you're not familiar with some of this stuff, just to kind of show you what it is. And I want to kind of break it down as we go over the topics that have to do with logging and monitoring and advanced cloud ops that are not those ones that I told you we wouldn't talk about. And this is a fairly simple application, but I wanted to do it like this. I did it like this very intentionally so that we don't get bogged down on details, on scale, those kind of things. Really, I want to create a framework. I want to talk about a framework for thinking about these kind of things. Well, what should I be thinking about when I'm thinking about logging or monitoring or security? What should I be looking at? And so let me kind of go over it a little bit. Okay, so this is not a very, this is pretty basic application stack here. We have a React website that is run out of an S3 bucket using CloudFront distribution. So it's a CDN network, and it's fronted by a AWS WAF. So it has a web application firewall in front of it. Behind the scenes, there is a API that's running as a container in ECS, though it could be Kubernetes if you wanted, but it's fronted by a load balancer, and it's in a private subnet, so it can't be accessed. The PostgreSQL database is a serverless one that's running on Aurora serverless, and it's also in the private subnet, can't be accessed. Also, the Elasticache for Redis is in the private subnet. So all this is kind of private, not publicly accessible. The only way that it can be accessed is either through a bastion or through the application load balancer that has a whole bunch of rules on it on what can access it and how it can go through. Also, this application that's running in a container uses a VPC endpoint to access the S3 bucket. All the AWS services that I'm not going to get too pedantic on this, but they're all publicly accessible services. So you have to create a way for it to go over private network to get to it. Otherwise this thing would have to go through the NAT gateway, out the internet gateway to get to it. But anyway, wave of the hand. I just wanted to kind of explain the application just a bit. Okay, so let's dive in. Let's just start talking about these topics and get it rolling. Okay, so the first thing we're going to talk about is monitoring and management. This talks about continuously monitoring cloud resources to ensure they're performing effectively, securely, tracking all the performance metrics, setting up alerts, managing resources as needed. This is an infrastructure-focused thing. This is, hey, is the infrastructure that we have out there, is it working well or is it working poorly? How is my application stack performing on the infrastructure? How do I know if it isn't performing? Okay, so let's kind of look at how that would overlay on the sample application that we looked at. And this isn't exhaustive, by the way. I just put a couple of things in here to think about. Okay, so effective management of the Bastion server. We might have automated patching of the Bastion using, say, Patch Manager in AWS, though there's other options that you can use in other cloud environments, not just in AWS. We may also have a CloudWatch alert if the CPU of the database gets above 90%. So we are running a serverless, but they do have kind of a monitor on the CPU, and they have limits on the ACUs, the compute units. So we may have to partition more compute units or make more compute units available if the database is getting above 90%. Okay, so also you can look at the metrics that are viewable in Container Insights. So this is, how is the container performing? One nice thing about running containers in something like ECS, you get a lot of these metrics for free, and they just absolutely, you don't have to do much. It's just kind of wave of the hand, they're there. And so that would be another example of how you would implement monitoring and management portion of things. Is you could look at the metrics on the container, see how much memory is being used. How is the container being utilized? Are there maybe containers that, in the task definition that we want to get rid of some tasks because we have excess capacity on the containers? The containers are not really working that hard, but we're paying for them. So maybe we need to think about that. Okay, so let's look at the next thing. Okay, so the next thing is log and event management. That's another thing that you need to be thinking about when we're talking about cloud operations. Collecting and analyzing logs and events to detect and respond to security instances, troubleshoot issues, and improve resource utilization. This one is very much an app-focused area, though it may reveal hardware problems. If there is a problem with, say, an application running out of memory, you might see an event that the application says, hey, I'm running out of memory. Maybe that points to a hardware problem. That is, we need to give more resources to it. But this is more of what's happening within the application, not what's happening with what the application is running on. Okay, so some of the things that you would look at and say this application is all website requests are logged by the WAF. The WAF would go in and say, hey, we see something going across the firewall here. We're going to let it through or we're going to block it. Some of those requests are getting blocked. Maybe some of those requests are getting flagged to say, this is not, we're not going to block this, but we are going to say that this violates a certain rule. And maybe you need to go look at this later. So all changes in AWS are logged via CloudTrail. So this is something that audits the AWS APIs. So if you call an API, you use the CLI, or you do something via the AWS console, it'll get logged to CloudTrail. So you could see if anybody on your team or maybe an unsavory actor is trying to change something within your AWS environment. All the database connections are getting logged. That's something else that can be consumed and brought out here and analyzed to figure out if there's a problem there. Maybe there's only one user that ought to be hitting the database ever. If there's somebody other than that user, then we need to do something about that. Application logs are collected and piped to CloudWatch. Application logs in using ECS is real easy. You can just set it up to go to CloudWatch and just no problem. You can just go through them. You can search through them. You can set up alerts. Very nice. And obviously, this isn't AWS specific. Application insights and stuff in Azure would be good. The GCP equivalents are good. Okay, so let's talk our next area in advanced cloud operations. Let's talk security. Cloud operations teams are responsible for implementing security measures, access controls, and ensuring compliance with regulatory requirements to protect data and resources. That's a mouthful. One thing that's interesting is some companies do have whole security teams that are responsible for a lot of this. Sometimes those security teams are doing some of this implementation, but a lot of times it's the platform engineers that are doing the implementation, and the security teams are the ones doing the cracking the whip if it hasn't been done according to regulatory requirements. So if you were doing any platform engineering, if you have moved something to the cloud, chances are you're going to be involved in the security portion of things. So the questions you want to ask, things like, who has access? And then who's getting in? So who has access? There's a list of people that have access. Who are those people? Or do they have too much access? They have too little access. Well, if they have too little, they're probably going to ask you for more. But if they have too much, they're probably not going to tell you. Who's getting in? Well, what are the actual logins? Is anybody not using their login? Maybe we need to just expire that one. Disable that particular access. And then how do I prevent problems from happening? How do I prevent bad actors from coming in? They used to say with security that it's, I think they say now, the question is, it used to be, are we going to get breached? I think the question is, what do you do now that you've been breached? Because the way things are now, security is just, it's so difficult to keep people out. And companies have to respond when security breaches happen. So what do you do? That's a lot bigger topic than just our cursory overview, but I wanted to kind of go into it a bit. So let's look at security. Let's break it down in this simple application and some things that you could look at. Okay, so certain requests are getting blocked by the WAF. There are patterns of requests that are like, wait a minute, the only reason you'd make that request is if you were trying to fish for data or trying to break through somebody's security. So the WAF will block those right off the bat. The front-end application is password protected, accessible only over HTTPS. We are redirecting to, if somebody attempts to go HTTP, we're redirecting to HTTPS. These S3 buckets are not publicly accessible. We have a VPC endpoint for the API container to access the bucket. If we had to access the bucket directly, we may be using a bastion, though probably we would have to do some things differently to get that working, or there may be some RBAC things that we're putting in place to make sure that you can only access the bucket from, say, the console or from maybe the CLI. The load balancer is an additional proxy against DDoS attacks. I know with Amazon Shield is implemented on application load balancers, the basic version of it. They have a more advanced DDoS solution that costs a lot of money, but that's another place where it's protected. All the DB credentials are stored in a secrets manager. We don't have secrets manager on here as an icon, but we are not allowing the application to hold the credentials. It accesses secrets manager, then it uses the secret that it got to access the database, but it's not stored on the application that's running in the container. Traffic from the container goes through a private connection. We've talked about the VPC endpoint so that it comes through here. This container also has a role-based access to get to the bucket. So not only is it going over private network, but it also has to have explicit permissions to access S3 bucket. Okay, so yeah, actually, let's go into it. Let's talk a little bit more about identity and identity and access management. Controlling and monitoring the user access to cloud resources, defining roles and permissions, implementing identity and access policies. How do I control access? Well, let's look at how we did this on our application. Okay, so devs don't have access to production. So that's a very basic thing. We have software developers that are writing the software. We have a policy that the software developers do not have access to production resources. Only the people maybe that are deploying it have access. And maybe the people that are doing the deployments, the people that are operations people, maybe the platform engineers, maybe they don't have access to production all the time. Maybe there's an account that they forget the password of, but they break a break glass account so that if there's a problem in production, they can access it, but they don't normally have access to that account. Access is assigned via policies and roles, not directly to individuals. So, yeah, we have groups. We assign policies to a group, and individuals are in a group. We don't give God privileges to one person. The container, I already talked about this. I was talking about the S3 bucket. Container accesses the DB via RBAC, so we could do that. S3 access is granted via IAM through policy of least privilege. Okay, that is what I talked about a second ago. Okay. Compliance and auditing. Ensuring that the cloud operations align with industry regulations, internal policies, and facilitating audits and compliance checks. There's nothing, as a platform engineer or as a software engineer working on a team, there's nothing worse than when the compliance firms when the auditors come in and you're sweating bullets because you know we're not doing things right. The other side of that is there's nothing better than inviting them in and saying, we know we're doing everything right. We know that we're following all these compliance things. And then you get the report back and there's one or two minor things. They're like, well, you should have done this. And it's like, okay, well, that was a real petty thing. I know you have to put something on your report, so good, but I'm just glad we didn't find anything major. That is a great feeling to have that. How do we show others that we're doing everything correctly? Compliance is really, and passing audits is really about showing what's correct and not, and showing that we're doing things correctly, not that we're actually doing things correctly. Though probably if we're doing things correctly, that's going to show better in the audit. Okay, so let's look at some of the ways maybe you would do it on this sample app. Infrastructure is created and modified with Terraform only. So if you use an IAC, infrastructure as code solution like Terraform, maybe you don't make any modifications in the application itself. So you have auditability, you have traceability to show that all of your changes were made by the infrastructure as code. Running a pipeline, you can go through those pipeline runs and you can say, oh, I see where we created this container. Oh, I see where we put this policy in place. I see where this bucket was created. And you don't have just people going and creating things. The other nice thing about infrastructure as code is it really helps with DR. Oh, I think DR is maybe next. Maybe I shouldn't talk about that. Okay, I'll put a pin in that one for right now. Okay, so you can show that the database is not publicly accessible. We put it in a private subnet. There is no route to the internet that is a ingress and egress. There's only an egress route. Architecture was created using the 6 pillars of well-architected framework. It's always good to show the auditors and the compliance people these worksheets that say, okay, we created it like this, we did this, we did this, we did this, we did this. And you can hand that to them, and it just, the mountains of paperwork that show that we're doing things correct. That's a good feeling. The S3 data is all encrypted at rest. It's definitely all encrypted in flight too, because we're using secure connections to get to S3. So everything is 443, but it's also encrypted at rest on that one off chance that somebody could break into a Amazon data center and steal a hard drive, right? Probably not going to happen, but it's one of those things that they always look for when they're checking the boxes. Okay, DR. Let's talk about DR. Planning and implementing backup and disaster recovery strategies to ensure data and services can be quickly restored in case of an unexpected outages or data loss. Oh, man. Ooh. How do I get my app back if it goes down? That's the question we're really asking ourselves. So let's kind of dive into the app and let's kind of look at seeing what some of the vectors of VR are, that we can look at as far as executing a successful disaster recovery. Okay, so the thing that I gave away on the last one, infrastructure can be recreated with Terraform. So we have Terraform building stuff, and not only can we make sure that changes are only applied using Terraform, we can also tear everything down and start over with Terraform. Or if we had a catastrophic loss, we could come back and say, okay, well, we'll rebuild it. And then we'll execute it and pop out an environment. So you say, okay, you may be skeptical a little bit. You say, Daniel, we don't use infrastructure as code. We think it's a lot of overhead. It's kind of a waste of time. Sell me on it. Well, I'll tell you this. So I have put together Terraform in several different environments, and it is amazing to work on it a little bit, pop out a dev environment, and then they say, well, we'd like a test environment, a prod environment, and it needs to look quite a bit like the dev environment. Maybe the prod environment's a little more clustered, a little more highly available. It's a hard one to say. And I said, okay, give me a couple minutes. And then I hit apply. I maybe create a couple of extra files to handle those configurations for those environments. Hit plan, hit apply. Boom, all of a sudden we have a brand new environment. It's excellent. And it's really great for DR. Okay, so the database is backed up with a maximum of 5 minutes of data loss. This is something that you get with AWS Aurora. If you have a problem with your database and it goes away, it goes down, something happens, you can actually back it up with only about 5 minutes of data loss at the max. Sometimes it's even less than that, which is pretty good. You have the container images saved in the Elastic Container Registry. The data files are replicated to another AWS region. So they have a catastrophic outage in US East 1, which has happened. You have all your data files replicated to US West 2 in Oregon, and all of a sudden it's you can recover it. You got everything. You have the React code in GitHub. You have the container code in GitHub too. So even though you're building it in the registry and pushing it to the registry, you can always rebuild your container and push it again. Not too bad. Cost management. So let's talk about this. This is one of my favorite things. Managing and optimizing. Optimizing is the key word. Cloud costs is crucial. This includes monitoring usage, right-sizing resources, implementing cost controls to avoid unexpected expenses. What does it cost? Am I buying too much? Now, there's a little bit of a thing with this. I've been on quite a few cloud migration projects where I've heard management say something to the effect of, we don't care what it costs, get it in the cloud, and then we'll work out the costs later. And I'm always a little bit skeptical about that. Nobody would ever go to a car lot and tell the car salesman, hey, I want a brand new Mustang or Corvette or whatever you want. And I don't care what it costs. I just want it now. That feels like a very foolish way to do business and a very good way to get ripped off. You need to make sure and count the cost before you go to the cloud. What does it cost? And am I buying too much? The problem is a lot of times people will have these on-premise servers that are these big hulking pieces of hardware that can just crank out an immense amount of computing power. And then they say, oh, well, our application's running on a 10 CPU VM in our data center. So we're going to have a 10 CPU VM in AWS. And it's like, no, wait a minute, hold on. You can't just go from one to the other unless you know that it needs that. But if your 10 CPU web server in your data center is running at 1% all the time, well, maybe you need to right size it. So that's where optimizing the cost comes in handy. Okay, so let's look at this. Okay, so one thing you should do absolutely is set up cost alerts for when a cost passes a threshold. this is something that can keep you from overspending. And it can also tell you if something is wrong. I had a client one time that they had a life cycle rule where they were deleting files after a certain date. And, then they wouldn't be paying for those files anymore in S3. However, they were basically making them a non-current version in their life cycle rule. So they were making it a non-current version, but not actually deleting. They weren't finishing the whole thing. So they had like a slew of hidden files that was costing them hundreds of dollars a month because they didn't know those files were there. I went in and fixed what was done by a previous consultant, and it was all good. But if they would have just had a cost alert set up to say, oh, wait a minute, we expect our bill to be $200 this month, and all of a sudden it's $500. Maybe there's something wrong. Maybe we should go investigate. Something else you could do is if you have like a VM, like a Bastion server, this Bastion's probably only needed when you're doing some kind of maintenance or troubleshooting a problem. It's probably not good to have it turned on all the time because that is a vector of attack against this Postgres server. If they could compromise this Bastion, they could potentially have access to your Postgres server. So maybe you turn this off when you're not using it. It saves money on compute and also eliminates a potential attack vector for the Postgres database. Maybe you need to check the size of your database and downsize if necessary. The serverless database instances have gotten very popular lately, and it's a good way to kind of save on compute power. That is, have one that you can kind of, you really can't turn them off with AWS. You can't turn them off at 100%, but you can bring them down to a small idle where they're just idling very, 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 very slow. And then you can have it where they can ramp up if there's a need for it. That's a good way to check to see how your utilization is. You can access S3 via VPC instead of NAT gateway. This is one of those nerd arguments that are very, very prevalent when you start talking among cloud people. The NAT gateway is something that the traffic going across the NAT gateway out to the internet is more expensive than the traffic going over the VPC to access S3. So ideally, you want traffic to go this way, not this way to go out to access the bucket. So that's a cost-saving measure. However, there is a cost associated with upkeeping this VPC endpoint. So you do have to wait. You can't just say, well, we're going to use a VPC endpoint because that's what Daniel said. Not necessarily. The cost may be that we're only grabbing a couple megabytes from S3. So maybe we want to just go out the NAT gateway to get that instead of trying to go out a VPC endpoint. Maybe so. You have to weigh it out. You have to think about it. Okay, you only replicate the front end to certain nodes. Okay, so this one is running on a cloud distribution network. And the way it works is you have basically your JavaScript website, your React website, and it's in a S3 bucket, and it gets pushed out to these different nodes across the world. So you may have it stored in, say, US East 1 in Virginia, but it gets pushed out to, say, Frankfurt in Germany, or it gets pushed to Sao Paulo in Brazil, or to Beijing, so that people that are on the edges will have a faster access to your website. If you're a website, if you're say a payer for a utility company in Greenville, North Carolina, or South Carolina, either one. There's Greenville in every state, just about, I think. Probably nobody's going to be paying their water bill from Seoul, South Korea. So maybe you don't replicate that website out to that node. And, you know, if you do, I mean, if they are paying it from there, they can access it. It just might take them a little bit longer than if it would have been replicated out there. So this is the one I was talking about here, the creating lifecycle rules to delete old versions of the files. Make sure you test it. If you put any lifecycle rules on an S3 bucket, make sure and test it. Don't be like my former client that racked up a big bill on S3 because they didn't have those rules set correctly. Conclusion. So this talk was not meant to be in depth on any particular cloud operations talk. This is really a primer to get you thinking about how to think about putting cloud operations to work. A lot of the people that are platform engineers, usually most platform engineers come from one side of the aisle. They either come from the development side or they come from the operations side. Maybe they come from a different side. And I feel like a lot of the platform engineers that have come from the development side may not be as skilled in some of these things. So this is an idea to kind of get them thinking about this, because these things are very important. They're not the sexiest topics when you talk about logging or monitoring, but they're very, very important. And if you're in the cloud, as I was talking about with the shared responsibility model, you need to make sure that you are doing your part to keep your application safe and running. Thank you so much. And Lynn, I'll take any questions if there are any questions out there.
Okay. We don't have any questions at this time, but I just wanted to make a comment about something you said about not being the sexiest subject, but saving money, you know, having that cost management in there, that's pretty sexy for most companies. So I think they definitely agree. I really like the way you talked about optimizing, right sizing, and the cost alerts, which is really important. I've been in situations where they came in with the, you know, just build it and we'll worry about the finances later, from what you're saying. And it kind of comes back to bite them. So.
Yeah, so one of the things, Lynn, thank you for bringing that up. One of the things I think that's interesting is everybody, I think most of the people that migrate to the cloud, they do what is called a lift and shift migration. So they will take the assets as they are in their own on-prem data center and then replicate them in AWS. You are never going to get the best deal for dollar-wise, and you're probably not going to have the best operational excellence by doing that. That's probably a very good first step. It's, you know, it is a victory very much to get your stuff in the cloud, but adopting the cloud native services, that's where you're going to get the biggest bang for your buck. Instead of, deploying your own RabbitMQ or whatever. I'm saying it right. Anyway, using, say, SQS, a queuing system in AWS, or using Lambda functions instead of trying to build, like, have a server that runs a certain function or certain batch job. If you can do that in a Lambda function where you get like 1 million free runs a month, that is the right way to do it. That is the right way to use the services. A lot of times companies, I've heard this too. This is another thing that I've heard. A lot of people get very scared of what they call, what is it called? They get very scared of being like locked in. They say, oh, we don't want to use any AWS specific services because we're afraid of getting locked in. I think vendor lock-in is a myth, because I think that even if you had everything in, let's say, technology agnostic form, it's still going to take a little bit for you to move to say Azure or GCP or wherever your next stop is cloud-wise. You're not going to be able to just easily lift and shift again. And the other part of the vendor lock-in that I think is ridiculous is that, look, many of these services that AWS has or Azure has or GCP has, they are available in close form to their competitors because these guys copy and borrow. They're not gonna not have something and be like, well, that made the difference in us having this customer or not. So Lambda functions becomes Azure functions in Azure. So you can modify the code a little bit, refactor it a bit, and put it on the other service that you're using if you want to move. But moving from cloud service to cloud service is not an easy undertaking. Moving from on-premise to cloud is not an easy undertaking. It's going to cost you something, and you're probably not going to have the flexibility to move like car insurance, like where you're like, okay, I think we can get cheaper car insurance from Geico, so we're going to cancel our current car insurance and call them up, or we're going to call them up, get a better deal, and then cancel it. This, we're talking about your whole infrastructure of your company. It's not going to be easy.
Yeah, I am familiar with the lift and shift. It's a little bit painful to hear it because they get there and then they have no more budget to go further. So it's a tough decision. Well, I appreciate all your information today. Is there anything else you'd like to say before we close?
I don't think so. Just thank you so much for attending. I really appreciate it. It's always an honor to be able to talk for people, and I just appreciate you showing up.
Thank you, everyone, and have a great day. We appreciate your attendance today.
Thank you.
Bye.
Bye-bye.